Here I am presenting the synthesis and crystallographic study of diaminopyridine mercury-based 1D supramolecular polymer, and it is the introductory part. As the supramolecular polymer consists of such a distinctive class of functional materials where building blocks are developed by repetition of monomeric units held together with the directional and reversible secondary interaction. To study these kind of directional and secondary reversible interactions, such as intermolecular hydrogen bonding, metal coordination, halogen bonding, and various other sigma hole interaction with high directional properties, we have here reported a new diaminopyridine mercury 2 based 1D single crystal supramolecular polymer obtained, and it is the synthetic section. The compound was synthesized by treating 2,6-diaminopyridine in mercury chloride in methanol, and the reaction was followed by stirring with refluxing and to obtain a 1D supramolecular polymer of 1, and it is the 1D supramolecular polymer chain of 1, and it is the octave view. And here a plane was drawn to indicate a deviation was occurred between the two four-membered ring was due to probably formation of the HgCl bond, which can also be regarded as spodium bonding interaction, and it is the crystallographic data of monoclinic crystal system of 1. And the solution phase UV visible spectroscopy was also performed, and in solution phase UV visible spectroscopy, the spectrum was recorded in a DMSO solution, and two bonds were appeared in the region of 240 to 264 nanometer was attributed to the metal to ligand charge transfer transition, because here is the metal is in the D10 system, and another one at 300 nanometer was due to pi to pi star intraligand charge transfer transition of aromatic moiety. And the solution in solid phase photoluminescent spectra was recorded, and in solution phase spectrum, when excitation was performed at 260 nanometer, a intense broad photoluminescent band was observed at 356 nanometer was because of the intraligand transitions, whereas in solid state multiple series of a band was observed at 360 nanometer, 421 nanometer, and 485 nanometer. And comparing the solid and solution phase both spectra, it can be inferred that due to involvement of non-covalent type of interactions in solid state, there was a red shift of band was observed, and the solid state of crystal structure of 1 was stabilized by involvement of various kind of weak non-covalent interaction. Here I am dealing with a kind of HgH and HCl type of intramolecular hydrogen bonding interaction, and the bond distance between Hg and hydrogen of NH2 moiety was 2.692 angstrom, while the distance between H hydrogen atom and the chlorine atom was 2.903 angstrom. And it is the HgCl spodium bonding interaction, as we know that before various metals like main group metal and even transition metals were involved in a type of specific type of bonding interaction, which are known as like tetral. As for main group, it is a tetral bonding interaction, and for nickel, carbon, and hydrogen center, it is known as agostic and anagostic interaction. Likewise, here we have reported a newly coined term as is a spodium bond interaction between mercury and chlorine atom with a bond distance of 2.44 angstrom. In a supramolecular polymeric chain formation, and it is the crystal void calculation was obtained from Hertzsprung surface analysis, which indicates the empty space empty space, presence of empty space in the surrounding of the molecule with the crystal radius of 5.0 angstrom, and the data obtained from calculation was indicates the single crystal supramolecular polymer has lattice void volume nearly 31.07 angstrom cube and the void area 164.9 angstrom square. And these are the references, and here I want to acknowledge CSIR New Delhi for financial support in the former project. Thank you.